What up, fam? We are doing a solving an equation with two radical signs submitted by a viewer. If you have your own question, feel free to email me at Mr.RichardsMathVideos@gmail.com. Before we actually solve the equation, we have to make sure we know some facts. Here are the facts we have to know. That if you have a square root and you square it, the square root disappears. If you have a number in front of that square root, please note, not with the adding part, but with multiplying, you'll square the number in front, but the square root still disappears. You end up multiplying the two together. If you have something without any square roots and you just do a plus or minus b squared, we get a squared plus 2a plus or minus 2ab plus b squared. And if you change that letter b into a square root and you kind of combine these two ideas together, the a squared is still going to be there, the 2a is still going to be there, but now this square root of b is still a square root, and a b squared actually becomes a square root of b squared, which is just the letter b. If you have this stuff memorized and known in advance, it makes this problem much, much easier. I'm going to use this in the middle of the question. Let's do it. So here we go. Step number one. In general, you're going to be doing a multi-step process. What you're going to do is step one, we're going to isolate a radical. So isolating a radical just means getting one of these two by themselves. It does not matter which one you choose. I'm going to arbitrarily add this square root to the other side of the equation, and I'm going to end up with the square root of 2x is equal to 6 plus the square root of 36 minus 2x. So we just added that to both sides. We have isolated our radical. Step number two, we need to square both sides. When you're doing this, you have to make sure you're squaring the entire side. So the most common mistake students make is they'll square every single thing individually. They'll forget that you're squaring the entire thing. So when I say square both sides, we are talking about the entire thing squared. So this entire thing gets squared over here, and then 6 plus the square root of 36 minus 2x. And you are squaring the entire thing. So make sure you're being careful with that and not squaring just one of them. On this one over here, we're going to use our fact over here that if you have a square root squared, the square root simply disappears. And now we're going to use that formula I wrote here at the bottom. We're going to having a squared plus 2a square root b plus b. Let's do it. So 6 squared is 36 plus, and now we're going to have 2 times 6 times this. 2 times 6 is 12, and we have that square root 36 minus 2x. And then we're going to be squaring this thing. When you square that entire thing, the square root goes away. So plus 36 minus 2x. So there we are using that formula. Please note, if you don't want to use that formula, you are allowed to rewrite this as 6 plus square root of 36 minus 2x, and then times 6 plus square root 36 minus 2x, and do some FOILing, your first, outer, inner, last. But that's really going to drive you nuts on these problems because you're going to have to do it twice on every single question because we're still not even done with these square roots yet. So we're going to go ahead and simplify now. In order to simplify this thing, we're going to go ahead and notice that we have a 36 here and a 36 here. That's going to make that 72. And looks like we have a minus 2x and a plus 12 square root 36 minus 2x. A little simplified. Now we're going to go ahead and do step number 3. Step number 3 is isolate the other radical. Isolate the other radical. So you're isolating the other one, which means we need to get this guy by itself here. So we're going to go ahead and move everything to the other side of the equation. Yet again, we're going to add the 2x to both sides to get 4x. We're going to subtract 72, and that is going to equal 12 square root 36 minus 2x. This next step is technically optional, but it's going to make your life a lot easier. And that is to notice that the number 4, the number 72, and the number 12 all divide by 4. Because they all divide by 4, we can make the entire equation simpler by dividing by 4. Please note you do not need to divide anything with the square root by 4. You're dividing the numbers in front by 4 only. So dividing by 4 is going to give you x. Dividing by 4 on the 72 gives you 18, and dividing by 4 on the 12 gives you 3. You don't actually have to do that step, but if you don't, your life is going to be a little bit more difficult on the step number 4, because now you have to square both sides again. So square both sides again. So when you're doing this, square both sides. When you're doing these problems, your process is going to be isolate a radical, square both sides, isolate the other radical, square both sides. You're going to be doing that over and over and over again. So here we go. We're taking the entire thing. X minus 18 squared is equal to, and we're squaring again the entire thing, 36 minus 2x all squared. Using our formula we had written down earlier, a plus or minus b squared is going to be x squared there minus 2 times these ones. So that's going to give us 36x. And then 18 squared, happens to know that one off the top of my head. That's 324. And on the other side here, 3 squared is 9. And then the square root disappears. Let's go ahead and simplify this the best we can. We have x squared minus 36x plus 324 is equal to 9 times 36. That's going to be 324 minus 18x. Subtracting 324 on both sides makes the 324s go away. Adding 18x to both sides of the equation gives us x squared minus 18x is equal to 0. And then we can factor out an x, and we get x times x minus 18 equals 0, and therefore x is equal to 0, or x is equal to 18. It's possible that both of these answers are correct, that one of these answers is correct, or that neither answer actually works and the problem is unsolvable. So going back to the original equation, we're now going to substitute our answers into the question to see if they work out. There's actually another way to do this. I'm going to show that afterwards. So you're just going to go ahead and take that original equation and you're going to replace those x's with the value that we found. So we're going back to the very original one, and I'm taking this super original equation and I'm substituting in the number 0 for both of these x's, and then I'm going to substitute the number 18 in for both of those x's. So 2 times 0 minus the square root of 36 minus 2 times 0 is equal to 6. We're asking ourselves, is this true? So I like putting a question mark over my equal sign because I'm not certain yet. So 0 minus the square root of 36 is equal to 6. Negative 6 is equal to 6. No. So because negative 6 is not in fact equal to 6, we know that x equals 0 is what we call an extraneous solution. So we know this one is simply not going to be an answer that works for us. Now that we're going to go ahead and check 18 now. So if we check 18, we're going to be saying that we have 2 times 18 minus 30, square roots, 36 minus 2 times 18 is equal to 6. That's going to give us the square root of 36 minus the square root of 36 minus 36 equals 6. 6 minus 0 equals 6. Sure enough, oh, these are all question marks, whoops. 6 equals 6. That is a true statement, and therefore x equals 18 is our only solution to this problem. Yeah, that's pretty much it for this one. Like I said, there technically is another way. I don't feel like going over it. I think this is good enough for our extraneous solution check. Have a wonderful rest of your day and enjoy, I don't know, enjoy it, whatever. I'm just going to stop talking. Peace.